This is Minesweeper. Obviously, it looks very empty, but this is done on purpose to showcase the game itself. Right away, we can see that there are uncovered spots marked with frowned faces. This means they are quote-unquote flagged. We can click on numbers around flagged spots to uncover what is known to be areas without mines. After clicking on a mine, you can see the insides of the game, the number 9 being mines and the number O being empty places. We started with an empty 2D array. We covered it randomly with mines and then covered it with numbers that represented how many mines were around them in the squares adjacent. Of course, we had to stay in bounds of the array or we would get an error code. Here's the code that fills up the array with its numbers. This is what randomly filled up the array with the mines. We originally printed out the field in console and inputted our choices with coordinates. Of course, we had to hide the field for the user. And we were only allowed to click and open one square at a time because we had no idea how to uncover open fields that had no number or mine adjacent to them, until we came up with an algorithm for this problem. When you clicked on a tile, we would add 20 to the number you clicked on. If it were 0, then we would mark all around the spot by adding 10 to each square. This way, each spot marked with would be the only ones to show up in our GUI. The tiles that were above 10 would be displayed. Now we would traverse in a clockwise direction towards the next square that equaled 10, or meant it was an open field. Now we repeat the process and mark all around by adding 10. Here's another clearer and larger example. Right away we begin with adding 20 to the original spot where the user clicked. Then we add 10 to all the squares adjacent. Now we traverse upwards due to its closest clockwise proximity and add 20. Now we mark all around once again. This process went ahead and repeated itself recursively until there was no more 10s around the middle square. Of course, there will be squares that are open field that we may not have traversed on. The simplest solution was to create for loops that ran throughout the entire 2D array and landed on the first 10 it found until it no longer found any open fields. This solution, along with many procedures for this game, were very inefficient, and we realized we could have used hash maps or hash sets to immediately find marked open fields so as to lower our time complexity from big O notation n squared to instead n. The flagging system was actually relatively easily constructed and simple to understand. We right-click on an area we know has a mine, and then we middle-click on a number adjacent to this flag that can uncover hidden tiles. Of course, we would go ahead and then add 30 to the tiles that were marked with the flag, or a sad frowny face. Then we would display the sad frowny face in our GUI. Here is an example. And then here is the marked and traversed showcase of the game, where you can see the 30s, the 20s, and the 11s, all numbers above 10. Thank you for your time.